Good day, everyone. Let us pray. Heavenly, dear, loving Father, we thank you for this very beautiful day you have given to us. Bless the teacher who will impart knowledge to her students and to the students as well. Bless them, open their minds to become receptive of ideas. This we ask in Jesus' name, amen. Okay, so good day, everyone. Have a great day. How are you? Okay, so today we are reminded with the quote, stay positive, better days are on their way. So it's easy for us to be negative, especially when things are shaking and seem to be out of control. But let us always be reminded that we cannot control the situation, but we can always control how we respond to it. And let us choose to be optimistic because in that way we are opening doors for solution. Okay, so I am your teacher for today. I am Efefany Jane Humarito, or you can call me Teacher F. Okay, for your attendance, everyone, I'm requesting everyone to please open your camera and in one, two, three, give your best smile and click. Okay, so that serves as your attendance for today. Okay, so for our virtual classroom rules, always mute your microphone when you are not recognized to talk, respect, stay seated, and stay present. For a recap, okay, so our last meeting, our topic is all about lipids. And lipids are organic compounds that we can find in living organisms, and that is insoluble in water but soluble in nonpolar solvents. And in that lesson also we learned that about it's not you how much fat you eat, but what type of fat you consume. Is it a good fat or a bad fat? Is it monounsaturated fats, polyunsaturated, or saturated fats? Okay, so anyways, let's open up a new topic. So I don't know, let's jump from biochemistry to inorganic chemistry. But before that, we will have an activity first. We call this What Am I? So I have here jumbled letters, and then you will determine or guess the hidden word or words. Okay, so for number one, what do you think the word or the words? Okay. Yes, you are right. That's rate of reaction. What about this one? Mm, yes, say it. Okay, it's concentration. What about this? Okay, temperature, very good. Then we have, okay, particle size, collision theory, very good. Okay, so those five words we have learned: rate of reaction, concentration, temperature, particle size, and collision theory. So you have to remember those words because in the next activity, I have here pictures and then you will guess again the word. So out from you just choose from the five words. Okay, so in the first picture or in the picture, we have a bowl with boiling water, and we can really see that it's hot. Uh, the water molecules are evaporating or escaping in the form of steam. And in the second picture, so we have still that three glasses of water, but no, we can see also the water molecules in three different. intensity of heat. So the molecules are moving far. Okay, here it's I know it's compact, or they are nearly to each other. Okay. Now in the third picture, or in the third one, it's GIF. So you have an Erlenmeyer flask with a solution, and you can really see that the molecules are escaping because of it's moving also. It's moving because of the energy given by the flame. Okay, so what do you think is the word? Okay, the hidden word. Yes, okay. Okay, temperature. Okay, now what about this? The second, okay, you have you have atom A. In first picture, you have atom A and you have atom B. They bump, okay, and then they form the product. And you have molecule blue molecules and pink molecules. They bump and then forming another compound, which is one blue and two pink atoms. Okay. And in the third one, again, you can see that molecules are bumping and then forming another product. So, what do you think is the hidden word here? Mm, out of the five words. Hmm. All right, so that's collision theory. So as you can see, they are colliding and then they form. So in the undergrad, you already knew that collision is very important for a reaction to proceed. Okay, or for a new product to form. Okay, what about this one? You have at yellow atom and black atom. Okay, with the same proportion, 1:1, in forming a new product. In the second picture, you have coffee, a cup of coffee, and sugar. Okay, so if you are diabetic, it's not recommended, no, to add sugar into your coffee because coffee has already sugar, and when you add more, so that will become mm, concentrated with sugar. Okay, so what's the word? Yes, you're right, concentration. Okay, so those words that we have annulled, we have reviewed, they are five. And what do you think from those activity we had? What do you think will be our topic for today? Yes? Yes. So our topic for today is about kinetics, rate of chemical reaction. Now, kinetics is the study of rate of chemical reaction. So, kinetics tells us how fast or how slow the reaction has proceeded. Okay. Now, we have the learning objectives. Let's read first. Illustrate how various factors like concentration, temperature, and particle size affects the rate of chemical reaction. Okay. So investigate the effect of concentration in a chemical reaction through a virtual laboratory and generalize the application of rate of chemical reaction in real life. So I have here, okay. So let's move on to, I have here simulation, rate of experiment. So we know that those factors like temperature, particle size, Concentration, they are the factors that affects chemical rate of chemical reaction. They can speed up or they can speed down the rate of chemical reaction. So let's take a look or let's visualize how does concentration, okay, and temperature affects the rate of chemical reaction. So say for example, I have reactant A, atom A, and you have compound BC. So you have two reactants, A and BC. So what if I will have 5 of atom A and 5 of BC? Okay, and I want it to be cold, super cold. Okay, let's begin. Alright, so here are the atoms and compounds. Okay, so as you can see, it's not moving. Why? Because it's very cold and there is not enough energy for the molecules to move. Okay, what if we will change the temperature? Okay, we will increase. Okay, now it's moving. Now it's moving, and as you can see, so I have here a bar graph. So we have 5 of A and 5 of BC, and the product will be AB and C. But notice that there is no amount of AB and C that is being formed. Oh, right. Oh, here. It's not forming. Okay. So we can see that. And it's 2. There are 2 AB, as you can see, and 2 C. Okay, let's wait. Should we wait? Okay, all right. So it's in a note. It takes a little longer. So what about we will increase the temperature? Oh, now it has raised to 3. Okay, so this time let's increase. Okay, the temperature. Okay, all right. So as you can see, directly there is a product being formed. Okay, and the molecules are moving faster compared to the cold environment. Okay, so now we have here a graph that is the y-axis is energy with respect to the reaction coordinate. Now, as we can see, the green line here is the present or the total average energy that is present in this environment. Now we have here a curved line. Now the curved line or the highest peak of the curved line is what we call the energy of activation. It's the energy or the minimum energy requirement for the molecules uh, to surpass in order to form a new product. So if we lower the energy to the activation of energy, still there will be reactions or there will be to be formed, but very minimal. As you can see, more products are being formed here compared kanina na cold environment. Because in the cold environment, the total energy is below, okay, below the energy of activation. Okay, so what about we will increase, we want it to be 100 and 100. And we want it to be, ano lang, okay, dito lang, not, okay, that's below the activation energy. So what do you think will happen? Oh, then I will change the graph. Okay, so you can see, So as you can see, there are um, 30 to 35 products being formed. Okay, 30 to 35 products being formed. And the molecules are moving, okay, moving fast and colliding often. Okay, so what about if we will increase the temperature? Okay, what do you think will happen? Oh, the reaction is very fast, and as you can see, more products being formed. So it's from 38 to 45. From 38 to 45 when the temperature is higher. Okay, when temperature is higher, you can have, okay, you can form products 38 to 45 um, greater than the cold environment. And as you can see, the molecules are moving faster. So how does that happen? So the temperature, when we increase the temperature, as you can see, the molecules are moving faster because there is energy, or there is higher energy being supplied, and enough to surpass the energy of activation. And when that happens, so there is a higher chance of colliding to each others. And higher probability of collision, then that means uh, higher yield of products, and more products are being formed. Kanina nakita natin yun. Okay. Now what about when we increase the temperature? Kanina when we increase the concentration, rather, when we have 5 of A and 5 of BC, the collision is not that, the frequency of collision mahina lang. Hindi sila nagko-collide to each other. But when you have this, when you have the reactants increased, the number of it, you increase the number of reactants with the same volume. So the molecules are now very unstable and tend to collide with each others. So higher concentration could lead to higher collision and, of course, higher yield of products in more faster rate of reaction. Okay. All right, so that's it. So we will just pause, and then, okay, so let's relate. So how are these related? So I will be, okay, how are these related to real life? So what's the application? So you will be grouped into group 1, 2, and 3, and you will work, or you will be graded with this rubric. And group 1 will work on learning area 1, group 2 is for learning area 2, and group 3 will be on learning area 3. Okay, so let's start group 1. So you have here a picture of, oh, grilled meat, barbecue. We love barbecue. So, from this, what have you observed? If we burned a smaller piece of charcoal, will the food be cooked faster? Will it produce more heat? Okay, so ano na mangyayari pag maliliit yung charcoal? Will it produce faster heat? Will the meat be cooked faster? Yes. No, yes, that's because of higher surface area being exposed to the flame, okay, to the starting flame, and then magdakip siya ng flame, so mag-burn siya. mag-burn yung charcoal. And the same goes also to the to our food. Like say for example, if you have lechon, okay, so if the surface area, okay, the surface area of the in the surface area of the lechon manok, if the area that is being exposed to the charcoal is maliit lang, then the food will be cooked slower because maliit lang yung part na na-expose sa charcoal. So, will it produce more heat? Yes. Okay. How surface area and temperature affect the rate of reaction of the food that cooked using charcoal? So, the greater the higher the surface area being exposed, then the temperature will increase. And what about the rate of reaction? Since the temperature has increased, then the food will be cooked faster. Rate of reaction is faster. Okay, so what about learning area 2? Thank you, group 1. So we have here a refrigerator. Sana all. Ganito yung ref. Okay, so if we lower the temperature of the refrigerator, what will happen to foods? Okay, so if we lower the temperature of refrigerator, so meaning ano no, mainit. Okay, mainit yung frigidaire natin. So pag mainit yung refrigerator, what will happen? Now, the microorganisms that will attack your leafy vegetables will really love the environment. Okay, it's very habitable because of lower temperature. Higher temperature, it's very habitable for them. So that means that the food will spoil faster if mainit yung ref natin. But okay, will it take longer? No. So what will happen if we raise the temperature of the refrigerator? Now, if we raise the temperature, then we lower the rate of reaction. So that's why magtatagal yung mga fruits and vegetables natin in the refrigerator. Di ba nakita natin kanina, when we have the cold environment in our molecules kanina sa ating simulation, very cold, the molecules aren't moving. Okay. When it's not moving, there's no energy for the reaction to proceed. Okay, so that's why mag-freeze. So sa ref, 'di ba, mas magtatagal yung frozen one kaysa sa hindi. Okay, how could you relate this scenario to the rate of reaction? So, lower temperature or lower temperature meaning lower temperature is lower rate of reaction. And when we relate that to foods in the refrigerator, so that is more preferable. Lower temperature. Okay, I think I made a mistake. Lower temperature, sorry. So lower temperature, that's ano, um, hindi mainit because lower nga. So pag lower yung temperature, mas magtatagal yung food. Sorry, group 2. And if we raise the temperature, so higher temperature natin, if we raise the temperature to a higher one, then what will happen is mas madali ma-spoil yung mga food. Yeah. And okay, so let's move on to learning area 3. So if we cook small pieces of food, what happened to its surface area that is being exposed to heat? Okay, so when higher surface area exposed to heat, so that will yield a higher temperature and the food will be cooked faster. from the picture of the sugar, which is faster to melt? The granule one or the cube one? Okay, so just imagine if we have our sugar and it's as big as Eden cheese. Okay, so you might get late before you will be able to sip your coffee. So for this, mas maganda yung maliliit because higher surface area. And mas madali siyang ma-melt compared to the big one. Okay, so thank you group. Okay, thank you class. Thank you group 1, 2, and 3. So, there are lots of ways to determine the rate of reaction of a chemical reaction. So, if you are measuring, say for example, it's gas, then we can measure the rate of reaction by the change of pressure, the final pressure minus the initial pressure over time using your manometer. Also, we have when you have the colored substances, you can identify the rate of reaction through spectrophotometer by the change of absorbance of light. And neither way, we can always calculate, or we can always calculate the rate of reaction, or we can always calculate the rate of reaction by plotting it with concentration with respect to time. So I have here, from this equation also, we can see that rate of reaction. Like say for example, we have 2 dinitrogen pentoxide and then it forms 4 nitrogen dioxide and then plus oxygen. So as you can see, you have 2 of dinitrogen pentoxide, then it will form 4 NO2. Now if we're going to take the rate, we know that the rate of reaction is equal to the concentration, to the change in concentration over time. So that's why the triangle here is, we call the delta, and that's the change. And we have the bracket, that's the concentration. So the concentration of N2O5 over time, or the change in time. And notice that we have negative because it is the reactant. When you have the reactant must be consumed, or the reactant will decrease to form a product. So a rate of reaction for reactant is, we call that also rate of disappearance, and that's why that's negative, because it will disappear, and that is 1/2. So the rate of disappearance of N2O5 is 1/2 to the rate of appearance of NO2. So that's how you read that. And we have, so this is stoichiometrically equal or equivalent to the 1/4 because you have 4 as the coefficient, delta NO2 over delta T. And then also equivalent to concentration of oxygen over change of time. So from here, okay, this means that as one O2 or one molecule of O2 appears for every 4 molecules of NO2. So if we're going to say the rate, so O2 appears at 1/4 the rate of NO2. So NO2, the rate of NO2 is 4 times faster than the O2. And the rate of O2 is 1/4. Okay, 1/4 of the rate of NO2. And as well as the rate of appearance of O2 is 1/2 to the rate of disappearance of N2O5. Okay, so you can read, okay, that's for easier, you can read the coefficients here and in here as well for the rate. Okay, so another problem I have here, another problem. So hydrogen gas, okay, a non-polluting combustion product, water vapor. Okay, so the product is water vapor. It is used as fuel aboard the space shuttle and in earthbound cars with prototype engines. So this time you are asked to express the rate in terms of change in H2, O2, and H2O. So let's try that one. So we have here, so that is letter A. Now in letter A, that's simple. So we just write the same way to the previous example. So rate, we know that the rate is equal to the concentration of the reactant. Say for example, the reactant over T. Now, since it's reactant, so that's negative because it will disappear. And as well as that's delta for the product, okay, that's delta T and it's positive. So we will not write positive anymore. So this time we can write rate is equal to the negative. Okay, since you have 2, so that's 1/2 to the concentration of your H2 over delta T. And that is stoichiometrically equal to the concentration of O2 over T. And that's negative and is equivalent also to 1/2 change in H2O over change in time. Okay, so this one, so this is the rate of reaction in terms of H2, in terms of O2 and H2O. Now we have letter B. Now in letter B, when O2 is decreasing at 0.23 moles per liter second, at what rate is H2O increasing? So let's take a look at O2. Now O2, or the disappearance, okay, the rate of disappearance of O2 is 1/2 to the rate of disappearance of H2. Kasi mas mataas man mas mataas man yung 2 kaysa sa 1. Kaya 1/2 siya. And then, if, or shall we say, the disappearance of H2 is 2 times faster than the disappearance of O2. That's how you say it. And then, likewise or similarly, the appearance, okay, the appearance of H2O is 2 times faster than the disappearance of O2. Or we can say it this way, that the disappearance of O2 is 1/2 to the appearance of H2O. Okay, so for better understanding, okay, let's write let's solve this one. So when O2 is decreasing, okay, so we will use this equation, this one, because we will relate O2 with respect to H2O. Okay, so that is negative delta O2 over delta T is equal to the 1/2 of the concentration of H2O over delta T. So this is, it says that it's 0.23, so we just plug in. So 0.23 moles per liter per second. That is equal to 1/2 of the change of H2O over change in time. Now, to cancel 1/2, so we will multiply both sides by 2. So cancel, cancel, and then we are left with, okay, so 0.23 times 2, so that is 0.46 moles per liter second. And that is the rate of your H2O delta over delta T. So this is now the rate of your H2O. So as you can see, the appearance or the rate of H2O is 2 times faster than the oxygen. Okay, so we neglect the negative sign because again negative sign says qualitatively only that it is decreasing, and since we're calculating also for H2O, now H2O is positive because it's appearing. Okay, so much for that. So I will give you more examples on that through your assignment. But this time, let's have first your experiment. Okay, so let's have an experiment. So in the same group, so aside from the points gathered from your worksheets, so you will be graded with this rubric, and of course you will answer the observation, your tally, your the graph, and the follow-up questions. Okay, so everyone, please get your procedure or worksheet. So this is your worksheet that I have sent to you in our Google Classroom. Then we will move on to our virtual laboratory. Okay, so this time we will use the virtual laboratory from Amrita. Okay, so I have here, so here, this is our virtual laboratory. So imagine that you are in a laboratory wearing a lab gown. Okay, so take 250 ml of conical flask and label them as A, B, C, and D. Okay, so we have here your flask, and then in procedure 2, add 5 to 10. Okay, add 5 ml. Okay, let's add 5 ml of potassium iodide. Okay, let's set the volume. So okay, it's hard for us to set it into 5, so let's just take note that it's 6. So we will write in our observation data or data table that we put 6. Okay, how are we going to do that? Of course, we will measure 0.1 Ki, so 6 ml using our graduated cylinder. Then we will pour it to our conical flask. And then we will add, in procedure 3, add sulfuric acid that is 10 ml. Okay. Alright, so pour it to the flask. And then to make the volume of the solution, add solution 100 ml. Okay, so we're making this solution to 100 ml. And we know that we already put 16 ml. 6 from potassium iodide and 10 from from sulfuric acid. So to make it into hundreds, so we will add 100 minus 16, that's 84. ml of water. Okay. And then in procedure 6, add 10 ml of starch. And then procedure 7, oh, that's 5 ml starch and 10 ml sodium thiosulfate. Then finally, in procedure 7, we will add 3% of hydrogen peroxide. So that's 5 ml. Okay. Then we will stir using the stirring rod. Okay. Oh no. Wait a minute. Okay. Then we will stir using the stirring rod. So, okay. So how does that happen? Okay, 'di ba? At first we put Ki. Now, the Ki will dissociate, okay, dissociates into potassium ion and you have the iodide ions. So, we will use the iodide ions liberated from your Ki galing dito sa iyong potassium iodide. And then we add what? So we add sulfuric acid. So we add sulfuric acid. So that's acid. So I will just write uh, H plus because it will dissociate into hydronium ion or hydrogen ions. And then we have the H2O2. So we put H2O2. So that is your hydrogen peroxide. Now, hydrogen peroxide is an oxidizing agent. When you say oxidizing agent, it removes electrons from other substance. And in that case, it's from I, especially that it is under acidic condition. So under acidic condition, hydrogen peroxide acts as oxidizing agent and removes electrons from your iodide ions, making it neutral because the negative sign connotes that it has extra electron, and we get that we remove that extra electron, so that's why it becomes neutral. And we put 2 because again, iodine, fluorine, chlorine, hydrogen, nitrogen, they exist as diatomic atoms. So we don't have I alone, but we have I2. Then you have your water. And then, so this is the reaction. So we will just balance. So you have 2 here and 2. Okay, so I guess that's balance. All right. Now, notice that these are not the there we have only not only 3 we added. We have starch and sodium thiosulfate. So, what will happen? Okay, your iodine will react with sodium thiosulfate. So that is S2O3 2 minus. Okay, thiosulfate ion forming. Now, when you have I2 and S2O3 2 minus, so the I2 will be reduced. Okay, the I2 will be reduced, forming I minus. And you have plus S4O5 2 minus. O6 2 minus. And then we will just balance the equation. So you have 2 and 2. Okay. So as you can see, during the reaction, okay, now it has turned into blue color. Into blue color. So let's take note of the time. Okay. So the time is 3 minutes and you have 43 seconds. Okay, now in procedure B, okay, now not in procedure B, but in the second flask or flask B, we will do the same, but this time we will add 10 ml of 10 ml of potassium iodide. So that's 10 ml, and then we will add the same ratio for all of the solutions. Okay, then pour that. Then we add hydrogen or sulfuric acid. So we will add water, that's 80 ml. Then we add 5 ml of starch and 10 ml of thiosulfate. Then finally, you have your hydrogen peroxide, that's still 5 ml. So notice that we do not change the volume. Okay, we do not change the volume of the other solutions, but only with Ki. So this time from 6, we add 10. Okay, so that's 10. Now let's identify, or let's observe what will happen to the time, to the time when we add more of Ki. Okay, but let's go back. So while waiting, so let's go back to the equation, to the reaction mechanism. Okay, so this time okay, we were just producing more of I minus, okay, of iodide ions. And then of course the reaction will continue. It will continue until when? Okay, so just like, say for example, a fire. So when man mag-stop yung fire? Of course, pag mawala na yung fuel or wala ng panggatong, it will stop. Okay, so this time, here, the thiosulfate acts as your panggatong or your limiting reagent. It limits the reaction. Pag maubos na to, then the reaction will stop. However, okay, pag mag-stop na yan, so the extra I2, because we add more, we monitor the rate using the starch. Okay, because we add starch, so the I2 will react to starch because no more S2O3 2 minus. And when that happens, when I2 reacts with starch, then it will form a blue complex. Okay, kaya nangyayari itong blue complex because it's the I2 that reacts with your starch. It's the iodine that reacts with your starch that becomes blue complex. So, meaning to say that the time elapsed before the blue complex appearance, before the blue color appeared. So that gives us the idea that was the rate of reaction, the time elapsed before the blue color appearance. So it's the rate of reaction between iodide ions and then the thiosulfate ions. So we will take note of that in when we have 10 minutes, 10 Ki, so that is 2 minutes and 18 seconds. Okay, so actually I have finished this experiment, and when I tried it with 15 for the 15 for the third but conical flask, and so it yields, so that time elapsed was 1 minute and 20 or 30 seconds. But then we have 20. So that is 1 minute and 14 seconds. Okay. So we will just save this, and then to for us to quickly analyze, so we will use a graph. So that's a skill you have to learn in chemistry in the lesson. So that is, as you can see, as we increase the concentration of Ki, then the reaction rate is faster, meaning that time is lower. Okay. Okay, so I hope you are done. Group 1, 2, and 3. So this time, let's go back to our class. Okay, to our lecture. So this is, again, don't forget to answer your worksheet. So that has your data sheets, your table, then your follow-up questions, and your conclusions. Okay, and of course, for your output, please post it to our Google Classroom and in task, okay, in the classwork, particularly task. So please, I have created there the task 3 submission bin. So you submit it in task 3. Okay, all right. So I hope that's clear. Now this time it's comprehension check. Okay, so let's have a quiz. So I'll be giving you the link for the quiz, and okay, so you will answer that one. So that's okay, time is up. So I have now received your scores. And I guess so the learning objectives. So we have illustrated the various factors like concentration, temperature, particle size affects the rate of chemical reaction, and we also investigated the effect of concentration in the chemical reaction through a VLab and generalized the importance or the application of rate of chemical reaction in real life. So that's all for today. Thank you so much, and I hope you have learned. Okay, so for your assignments, so I've posted assignment in our Google Classroom. Please check on it. Okay, and that's all. Bye, everyone.